Hello guys, today we will learn about data quality and pre-processing technique in learning analytics. The challenge of data quality. Why clean and reliable data is essential for meaningful learning and analytics. Core data quality issues. Accuracy. Are the data values correct and reliable? For example, contradictory ratings, typos in course codes. Completeness. Is all necessary data present? For example, missing survey responses or skipped mandatory questions. Third, consistency. Are format and values uniform across the dataset? For example, 1 to 5 versus 1 to 10 rating scales. Fourth is timeliness. Data must be current to be useful. Feedback needs to be analyzed promptly to allow for intervention before the next term, not a year later. Validity. Data must conform to rules. For example, rating 1 to 5 and must actually measure what it intends to measure. For example, teaching effectiveness versus course popularity. Handling missing data. Discussing approaches for dealing with incomplete student feedback. Methods for missing values. Ignoring tuples. Deleting the entire row. Only viable for very large datasets with a tiny percentage of missing values. Manual filling. Using domain knowledge to fill values. This is extremely time consuming, subjective and not scalable. Statistically imputation. Filling with a global constant or the mean, median or mode. Simple but can reduce variance and distort data. Class specific imputation using a mean median for a specific group, for example CS students, for more accurate fill. Probable value methods using regression or k nearest neighbors to predict the missing value based on other data points. Data smoothing and outliers, techniques for removing noise and handling extreme values in feedback ratings. Smoothing by bin means: first, sort data. Arrange all ratings in ascending order. Second, partition bins. Group sorted data into bins of size 3. Third, calculate mean. Find the average value for each individual bin. Fourth, replace values. Replace all original values in a bin with the bin's mean. Other data smoothing methods are bin boundaries. Replace values with the nearest bin boundary, the mean or max value, instead of the mean. Regression. Feed the data to a line or curve and use the predicted values from that function as the smooth data. Moving average. Replace each point with the average of a window of its neighbors. Excellent for time series data. Detecting outliers. Statistical methods. Use Z-score, example 3 standard deviation, to identify points far from the mean. IQR methods. Identify any value outside the 1.5 into IQR range. This is the basis of box plots. Clustering. Use algorithms like DBSCAN to find points that are isolated and don't belong to any cluster. Visualization. Use histograms and scatter plots to visually identify extreme values that are detached from the main group. Key takeaways are: data quality is not an accident, it's the result of rigorous intentional pre-processing. Understanding your data flows, missing, inconsistent, or noisy, is the critical first step. Choosing the right method, imputation, smoothing, outlier detection, depends entirely on the dataset and the analytical goal. Thank you guys for watching. If you have any questions, please comment down below.